Hello, this is Stas and welcome back to second part of my render buffers and creative shading tutorial. The first part was about the basic setup and using rendering buffers without GLSL, and if you haven't seen it, I really recommend it to watch it first and then come back to the second part, because we would build on some information I explained on the first part. And the second part would be about using GLSL both on vertex stage and then pixel stage. And I will show you different setups and different ideas a bit later, but firstly let me show you the basic setup. It's about the same as it was on the first part. So we have a torus connected to the twist to make the geometry a little bit more interesting, and then connected to geometry we also will need the camera and the light, and of course we need the render maybe connected to the output, and we need Phong material, because it's much easier to start from Phong material rather than writing everything from scratch. Here on the render I set different resolution, and because I would use the render buffers for positions and normals and everything, it is better to use pixel format 16 or 32 bits float. Okay, and in the Phong material you need to set up everything. You need to activate every option you will possibly need on your GLSL shader. So if you need a MIT, set some values, add color map if you will need the color map. I don't know, let me use some noise for the color mapping. Noise, a bit of noise. Okay, and also in the advanced page it's a good to set up different color buffers. And by the way, you also need to set on the render on advanced tab, increase the number of color buffers. Okay, probably I will want to have a camera space position, camera space normals, maybe texture coordinate, maybe final diffuse, and maybe final specular, and one, because I like to use this one as a mask. Okay, and now I could press the output shader. Alright, and I could use this GLSL material as a material. Alright, and I don't need this Phong anymore. So, oh, by the way, let me twist. I have orientation on z-axis. Let me increase the number of rows and columns and twist it a little bit and maybe rotate it. Yeah, okay, looks good. So, right now we have oops, not render pass, render select. Right now we have the render buffers we could reach even without any GLSL, like camera space position, normals, textures, and diffuse, specular, and the mask. But with GLSL we could do something else. Okay, so here we have color buffer 1, 2, 3, 4, and 5. Alright, here is how it's organized by default. By default, it's the output set as the variable for number of color buffers, which is this one, showed here as an array for off-rec color, and off-rec color then used here as this for loop, and for every case, for example, for color buffer number 1, which is camera space position, it's output for camera space position, so this is a formula for camera space position, this is for camera space normals, this is texture coordinate, final diffuse, final specular. But you could of course feed something else here, and also it's up to you to use this structure or to use output like this, off-rec color, without these switches and for loops. Or you could even rename from off-rec color to give it some meaningful names. And you will see on later examples how I did it in different ways. But here I leave it like this, and because it's just a demonstration of how you could change the things. For example, here let me call it camera space position, camera space normals, and for example, if I want to have world space position and world space normals, because for different kind of shading it's useful, very often it's useful to know the world space position and world space normals. And again, I'll show it later how you could use it, but let me just show how to set up it. So world space position, it's super simple. Here we have ivert, world space position comes from vertex stage, and you could just copy paste this part. Let me, for example, the last was a 5, so I put it 6. 6 is a 0. All right. Here I have 6. I have 8 buffers. So, okay, I will need to delete this one because I have only 8, and I'm already, and this one is also counts. So here I have already 9. So it's not good. Okay, 6 and 7. So I need to change. I wouldn't have the mask here. 6 and case number 7. All right, here we could copy paste this for 6. So here we have a world space position now, and of course it's different from a camera space position. And if I move my let me transform it. Let me transform it here. If I move my or even if I rotate my geometry, as you could see, the world space position changes. If I do it on the geo, it's also changes. And meanwhile, the camera space position stays the same because it's always the vertical, horizontal, and the depth. And of course, the depth will change, but not so drastically as in world space position. and the same would be for normals. And for normals, here we have camera space normals, but it's not that easy as in this case. But you could see the camera space normals comes from here. Comes from here, and here you could find the world space normal. So you could, for the case 7, just copy paste here, and actually it's use also world space normal. So now you have world space normals. It looks about the same as a camera space normal, but if I move camera much more, now it looks different because my camera space and the world space is really different. It's not on the same line. And if you go to the GLSL material on the wiki, you could find a lot of different other variables that you could use here. And just let me show you some. Let me replace this specular to something else. Maybe I want, I don't know, what could I don't know. Here I have some view vector. View vector is some normalized values from the camera. So it's camera space position minus world space position. Maybe I need it for some reason. So if I change it, here I have this view vector, which is one color because it's it shouldn't be actually the one color. Oh, it's different. It's just the green is much brighter, or yeah, the green, which is shows the XY position, it's much brighter, so it seems like it's one color, but if you look at these values, it's not the one color. Okay, and this is the way how you could set up different color buffers in GLSL. And here all examples use vector free, so vec free, and the alpha channel sets to 1, but of course do I have something with vec 4 out color? Okay, I have this, probably it would be just white color, but or maybe I have something else, vec 4. Okay, anyway, the idea is that you could use vec 4 as well. For example, here I could change the final diffuse to vert color. Okay, and now it's changed. It's this one. Okay, that's it about the setup, and let me show you different examples. And this time I will share for everyone these 3 examples, because it's much simpler to show you how code is made rather than redo everything from scratch, because if I redo everything it would take a couple of hours. So I will share these 3 examples for everyone, and these 2 for my Patreon supporters only. So first example is the lights. Here we have 4 different lights, and I'm using the, as you could see, in the end, I'm not using anymore this construction. I use the free color with just normal rendering, this one, and I like to have a texture coordinate, which is this one, and just use just two lines. Is this one and this one, and another four, because I have four lights. So here I have the, even though it's say the location number 2, actually it's location number 2, 3, 4, and 5. It calls the variable calls OL, which is output light, and here how it's set it. So here we have a simple setup, default setup is the same as here for the lighting, but I output the lighting separately for every of my lights. And let me first show you the simpler one, because usually what this construction does, if I comment everything, it calculates the diffuse contribution and specular contributions and add it and do it for every one of lights, and then use these values for rendering everything. So if I want to do it separately for every light, I could output the diffuse contribution and specular, add it with specular contributions, and it will look like this. Here we have diffuse and specular. However, if you then add all of these light contributions, the result would be this one, the result, and then you also need to add the texture. Let me explain right now. Here is my texture, and I remap it with a texture coordinate, and that's why I need this texture coordinate. And I think I explained it in more details in the first part, and multiply it because that's what's happened in the rendering setup. Here I have a color map, for example, color map, and it's used to color map to this variable, and in the end it's multiplied to this. So here I multiplied it here, but the result is very different from the rendering. Why is this? Because if you read more closely what's going on the final, the diffuse sum, so diffuse for all of the lights, then multiplied by diffuse color, which sets on the Phong, on the vectors page. It's, if you use the Phong, it's here, this diffuse color. It's okay, let me show you in more details. This diffuse color, when you press the output shader, all the values comes into this variable, uniform diffuse color. Okay, so it's multiplied by this value, and also the color comes from the vertex stage, which is right now is white, but if you use the instances and you set some instances coloring here, it wouldn't be white probably. So that's why you could output for every light not just diffuse plus specular, but diffuse contribution multiplied by diffuse color and invert color plus specular contribution multiplied by specular color. And right now if I save it, and the absolutely the same setup. And now, if as you can see, the results is the same. Well, actually it's not the super same. Here I have a different stop, and as you could I'm not sure would it be visible or not on the record, but here you could see on the values that I have a tiny difference between those two. Maybe it's because it's calculated a little bit different. Maybe I didn't understand correctly something and I made a mistake, and if you found this mistake, please let me know. Or maybe it's just a difference in this remap and texture, or maybe it's just a super tiny difference in the float number. Then with all multiplication it comes into a little bigger difference, but still it's almost invisible, so almost no difference. All right. Also, here I comment this shadow string because I don't use shadow on my lights. And you could go into where is it on the wiki page? Here on the phone lighting, there is a different very handful made setups for different types of phone lighting. For example, if you want to use diffuse and specular but no specular too, you use this code, and if you diffuse only without specular, without shadow, this tiny one or this tiny one, and you just need not just copy paste but to feed with parameter. For example, I think I use about this one because I have a specular but no specular 2 and no shadows. So here I have my diffuse contribution, which is will be calculated, and that's why it's output. Specular contribution, the light index is I, because here for every of lights the TouchDesigner set the corresponding number. For light 1 is 1, for light 2 is 2, and so on. So world space position, world space normal, and this view vec, a vertex to the camera, and the shyness. And you could even delete this string, it would be working as well. Okay, and you could use with this setup you could use any type of lighting. For example, here my light is connected to the geometry, here my light is connected to the camera, this two is not connected, this one is point light, distant light, cone light, and this is cone light with also projection. Here is this projection, this is projected, and everything would be calculated automatically, and this is super nice. And what could you do with this? It's totally up to you. It's creative shading, so just be creative and do something with it. And here is my super clumsy, super fast example. For example, I took this cone light, add some noise to this position, add second layer of a noise, a little bit of adjust, and that's why I have this strange speculars that comes from this cone light. And if I move this light, oops, forgot to activate it. If I move this light, this noisy thing would move as well. And right now it's not super fancy, super good, but as always, a lot of time. I need to spend a lot of time to make it looks nice. It would be just testing different noises, different tops, fine-tuning the parameters, and you'll get some nice looking result, hopefully. Alright, this is all I wanted to show with lights, and you can grab this example for free on the link I'll put below in the description. And let's go to this BRDF. My initial idea when I start doing this was to test not the Phong model but different shading models, because there are a lot of, well, not a lot, but several different models of shading. And for example, here this Cook-Torrance BRDF models, it's more accurately represent physical reality of light reflectance than the Phong and Blin Phong, and but the same, it's a little bit more easier than PBR material, but it's something between PBR and the Phong. And there's a lot of equations, and if you're a mathematician you could probably convert all of these equations into shader code, into GLSL, but I'm not. So what I'm doing, I'm going to Shader Toy, and I found this nice example with Cook-Torrance sample BRDF. And even though this is ray marching, it's not polygonal geometry, the calculation for the shading is the same. So here's a code which requires the normals, which we could have as a color buffer, lights, no problem, from a vertex, camera, direction from vertex to camera, and the diffuse, specular, and roughness. So here is my setup. And my first setup was I just feed the light position and the camera position from the camera parameters and the lights parameters. So here 0, 0, 10, 0, 0, 10, everything works fine. And the thing is, it's not the best way to do it. That's why I have this second example. Now let's dive into code. What do we have here? Okay, and here I set up the output color buffers for the light space position and the camera space position. I found this this formula somewhere in the wiki or in the forum, but you could use it. Sometimes you need to read all of this, because there is a lot of interesting variables you could find, but yeah, sometimes it's tricky to find something that you need. So here I have a light and the camera, and it seems like it's the same. For example, 005, and here I have the same 005 and the camera 005, nothing interesting. But on the light it's different, because the Z position, which is blue, is 15, while here I have 10. Why is this? That's because my camera is connected to the light, so this translation from the light is also added to the translation for the camera. And if I start to rotate my camera and do something, the difference would be more and more and more. So it's a very nice way to feed it from color buffers. The other way would be, for example, if I change from a camera, normal camera, to the arc ball camera. Here I have arc ball camera. If I start rotate, as you could see, the difference becomes even more. Even more drastic, and this doesn't look right, while here it looks better. What I'm going to say? Oh, the other way could be to use the transform matrices. You could see how it's set on this arc ball camera. It's from a palette, and you could, if you haven't worked with transform matrices, you could see the example from the point cloud transform, I believe. Yeah, here is transform matrices, but not in the data, but in the chop that feed into GLSL, and you could see here how it can be used, but it's not the topic of this tutorial. So I'm not using the transform matrices, and I'm also not super familiar with it, so I'm using these color buffers instead, because this is our topic. So here is it's absolutely copy-pasted code from this one, this function, the radiance function. It's copy-pasted from this nice shader, and if you use it for commercial, it's good to find do we have some license here, or contact with the author, even though it's 6 years ago, so maybe it's not so easy to contact, but you could figure out what to do with license here. Anyway, here we have this function, and we need it. Let me copy here. To use this radiance, what we need is the normals, and here it comes to the second input from the normals. It's absolutely the same as I showed in the first example. So here I have a normals from the input number 1, which means number 2. The position, it's world space position. Here I have the light, the camera, and I found that I need to normalize the difference between light position and the geometry itself, and then I could feed it into this radiance function, and this is how it works. And you could set this roughness of material and get different looking shading. Alright, and you could find on the shade editor different types of shading, different types of BRDFs, or different Phong models or PBRs, and test some of them. And by the way, if you're one of my Patreon supporters, you would also get these 2 extra examples, and one of extra examples is about the same BRDF models, but I made it a little bit earlier, so I didn't realize I could use this trick with camera space position comes from comes from my color buffers, so here it's not super great because I feed it from the light itself and camera itself. But this is creative shading. It's absolutely not physical based, and if you're doing something creative, you could, here for example I have my world space position, but I add noise to it, and I add noise to the normals, so it's absolutely wrong. The position is wrong, the normals is wrong, but I like the result. So I experimented a lot of compositing, and here is a result. And here I'm also using the fog. The fog is fog is explained here on the wiki. You could try to implement it by yourself. It's a nice exercise, and it can be really useful for some as an alternative to the depth top, because the depth top is about the same. And I use the top, do the compositing, and so on and so on. And yeah, that's it. All right, and if you have the light and the camera as the inputs, you could also play with it as well, which could be really strange. For example, if I use some noise, again 32 bits float, the same resolution, not monochrome, something like this, and if I composite it with, for example, the camera position, the result is really strange now, because chroma difference, the soft light or something else. Let me just do average maybe. What was the first one? Or it was the multiplication? Okay, multiplication is good. Because what was going on is that the different parts of the geometry of things calculated as if the camera is on different position. So if I stop it, so by default in physical reality we have one camera, and for my camera, for the all of geometry, the camera position is the same, because we have only one camera, only one lens, and the position are the same. But if we add some noise or do some displacement or something else, then for different parts of geometry, the position of the camera is positioned in different points in the space, and the light, the shading is calculated as if the camera is in different position for different parts. Or you could do the same. You could do the same for light. Composite. Do the light. Let me animate this noise. Oops, too fast. And the more compositing and different noises I will add, the less and less physically accurate the shading would be. But if you up to creative shading and doing something really strange, by the way, I need to set what's going on. Oh, I need to rotate it. So for creative shading, you could experiment and not be stopped by physical based reality. All right, and let's delete it and leave it better. And the last one is about the instances. In the first part of this tutorial, I showed you how you could use the color of instances to, for example, to how to say, to separate some individual instances. It was looking almost like this, and I also have these strange artifacts, and afterwards I found how to get rid of this, because I thought it was something with pixel formats or with interpolation, but no, it's about the anti-aliasing, and if I set anti-aliasing to off, you wouldn't get these artifacts. But it's not an easy way to use all of these thresholds and compositing to separate some of instances. The much better way to do it is to do it in the shader itself. Here I have the same chosen instances on the shader itself. Here I could pick how much of them I want to leave these trails. For example, I could be from 25 to 26, and only one of my, which one? Only one. Okay, let me do it. Maybe it's somewhere in the very deep, so let me increase. Oops, 99. Okay, here is two picked one, and only two of them leave these trails. Actually, only three of them, but I couldn't find where is the third one. Or maybe it's okay. Let's dive into code and we will see why it shows only two. Probably it's because I'm using the different comparison. Okay, what's going on? For the instances, I use this for the position and some colors, and I rotate the same at the position, so it doesn't look super nice, but okay, it's only for demonstration. I have a tube. On a point, I add the custom attribute point index, so I could get the point index for any of my points on the vertex stage. And I also, from the null, I'm using sop2dot to extract vertices. I'm not interested in the vertices information itself, but what I want is to know the number of vertices, because I couldn't extract it from this info, and I don't have a variable for this, so this is how I did it. This is just the number of rows in this table minus 1. So I have 4900 vertices. yeah, 4900 vertices. And for number of points, I'm using just this variable num points, and I also add the variables for number of rows on tube and number of columns on a tube. And that gives me a lot of information I could use on a vertex stage. And by the way, I have another tutorial about what you could do on a vertex shader, and if you're not familiar with it and with all of this code, you could follow this tutorial, follow that vertex shader tutorial. But right now what you need to know is, here I set the uniform of all of these numbers, and I'm using it here to create different variables. I want to have the tube number, which is instance ID plus 1, because the first instance would be a 0, and I prefer to name it not 0 but 1. I have this tube ramp, I will show it later. And here is a different type of calculation of the same value. You could use any of those. The tube tube column, which is calculated from. So here for the tube ramp, here is my tube ramps. So every tube, let me pause. Every tube goes from 1 to 0, from head to tail, because maybe I will want to have this information. So here I have a tube ramp. I just use the fractional part of vertex divided by the whole number of vertices. For the column, I'm using the point index. The point index, it comes from the point SOP, and you need to declare it in the beginning. And so I have the point index of a current point, I have the total number of points, I have a total number of vertices, and I could calculate a lot of different variables. And here how I calculated the peaked tubes. For here I have a variable upeak, and in this variable I have only those tubes that would more than 25 and less than, and less than 28, so it would be only 26 and 27. That's why we have only 2 of them. Probably you could set it like this if you want some of these borders to be included. Anyway, and now as a general rule, excuse me, a little dehydration. All right, as a general rule, on a shader pipeline, the vertex shaders comes through geometry shader if you have a geometry shader, and then it comes through the pixel shader. So if you extract some variable, some information in the vertex stage, like here I have all of these tube calculations, and I want to use it on the pixel stage, I need to output it. And here for output I set these tubes, and the other one was here by default, and I only add these tubes, and in this tube over output vertex tubes I paste this number of tube, this ramp, this the column, and it picked tube. And then on the pixel stage, tubes. And by the way, here is a different way of outputting. Here I have different names, and I declare it here, and I output it in different stage. So here are tubes. Where is it? Where is it? Here it is. So I output directly from the input from the vertex stage. So I output this absolutely this without any modifications. And by the way, maybe you didn't know this TD output swizzle. Somewhere on the wiki it says that it's really important to use it, because on the Macs, on maybe some other GPUs, sometimes the alpha channels comes to the red channels and do some different crazy stuff, and TD output swizzle do everything works both on Mac, on PC, on different GPUs. So it's very good to use it. But here I don't use it because on my GPU everything works without this TD output swizzle. And sometimes I'm just too lazy to copy paste it. But if you work for clients, it's good to include it every time. If you work for yourself and do some video for Instagram or for something else, you could use anything that works. And in my case, to the output, it's not super necessary, but it's good to use it. Okay, let's back to this. So here is my output with these tubes. And because in different channels I have different informations, number ramps, I need to, and then I output it to 3 different tops. And it turns out that if you use the monochrome top for this one, this monochrome top, it converts everything. Even though it sets to pixel format to 32 bits float, the all values it comes from, it clamps at 1. So if you need here, for example, I have the huge IDs, you could see it here, the very huge IDs for every tube. You couldn't use the monochrome, you need to use reorder and set every channel as red, because here I have numbers to be picked. So here I use alpha channel from my output to choose this picked. Let me increase, by the way, let's do something like 45. These picked tubes, here is my ramps. And one way of use it is, for example, here with a threshold, I'm picking only the last or the widest part of this tube, and I'll use it later. I multiply it with levels, and I use it for feedback for these trails, because I don't want to the whole tube leave this trail, but only the widest part of it. And the color ramp is just I'm not using it, I just showed you because I have the 4th channel, and why not? And if I, for example, Sorry, I'm a little bit lost. What do I want to show you? Okay. To be pick, to be color. For example, if I multiply it by V and human Z, I could get this crazy looking stuff. And here is just different ideas you could test and you could output. All you need to know is that you have the current point, you could have the current vertex, you know the total number of points, total number of vertices, and you know the amount of rows and columns on a tube. And you could manipulate all of these numbers to output something you could possibly need. Right now I don't need it, but yeah, you could do whatever you want. And for the color, instance color, you just use TD instance, the color that comes from the vertex stage, which is just the instance in color. This function, it's reference it to these instance parameters and give you these values. And then you combine it somehow, do something with it, and here how you could use the instances. And let me show quickly the Patreon example. Oops, what I want here. The Patreon example here is about the same, but with a lot more compositing. And I'm using these trails to displace my final composition of rendering and BRDF. And again, here is my old BRDF if the position comes directly from the components. And here you could also see that if you set the row variable really high, you could have this translucent, interestingly looking material and use it for your compositing. So that's all experimenting. And I really could motivate you. I want to motivate you to explore the different shading models, and you could find many of those shading probably. If I tag shading on Shaditor, there is different shading models, and you could try many of those. And by the way, I have a tutorial about how to convert shaders from Shader Toy to TouchDesigner and integrate it so it wouldn't be just simply converted, but also integrated with different chops and tops and everything. But for these setups, usually you don't need to convert the whole shader, you need to use only some of the functions from the shaders. So that's it for this probably very long tutorial, and I hope you learned something useful, and you get now probably could get some new ideas how you could use the color buffers, and you could support me on Patreon and get these 2 extra examples, or you could just grab this from the link I leave below. And also I really wanted to look at your example. If you use this tutorial, I'm interested in what you could achieve with it. So please send me links to this or tag me on Instagram posts. I really wanted to see, and maybe it gives me some other ideas how I could use this technique. And that's it for today. Goodbye, have a nice time, see you.